Hello everybody and welcome to episode 41 of the video series in which we program an entire video game from scratch in the C programming language. So, episode 41. Trying to remember what we were doing last time. Oh yes. Last time what we were doing is we were in the process of converting the loading of all of our assets from just loading the files directly off the disk to now we're packing the assets into a compressed archive, and then when the game launches, it is unpacking the assets from the compressed archive instead of just loading bitmap or wave files directly from the disk. So uh, today we're just going to keep going with that. So last time we were working on this function, load asset from archive, right? And I've added some comments here. And all right, so last time we did that function right there, load wave from memory. So let's just keep going with the same theme until we get all these done. Load aug from memory. It's going to take a decompressed buffer and a resource. That function doesn't exist yet, so we will go create it. Tile, load asset, load wave from memory. Dword, load aug from memory. Takes in a buffer, pointer to a buffer, and this is going to do the same thing where we're populating a game sound data structure. That should do it. Alright, load wave from memory. What I'm going to do is the same thing I did last time, where we go to the load aug from file function. I'm basically just going to copy it and paste it into the new load aug from memory function and remove all the bits in there that have anything to do with the file on disk, because this function is not reading the file from the disk anymore. So we're not going to need file handle. Probably not going to need bytes read. Probably not. We're not going to need file buffer because we already have a buffer. I think that should do it. All right. So this create file part can go. Get file size ex can go. Don't care about that. We no longer need to allocate memory because we've already allocated the memory when we decompress the thing out of the assets file. So we just flat out don't need this anymore. Read. Okay, so with this we read the entire thing from file into memory, which we no longer have to do. Alright, samples decoded equals stb vorbis decode memory. File buffer is now just buffer. We have no file size. Okay, file size, large integer. Alright, so that's interesting. We need to know the size of this buffer, so we're probably going to have to pass that in somewhere. Load aug from memory. We're going to have to pass in buffer size. go back over here to main.c, update this. Okay. See, because there's no way to know, there's no way for this function to know how big this buffer is. I think the buffer size has to be supplied by the caller. I don't think there's any other way to do that. So, all right, and this takes in an int. So we're going to do buffer size dot quad part channels sample rate decoded audio. Okay, and if that failed, then STM failed with Alex. And I can't do the file name because there is no file anymore. It's just from memory. Let's see. Game sound, decoded audio. Everything else I think is correct. So here's exit. We no longer need to do that. We don't have to close a file anymore. We no longer have to free any heap memory anymore. So that's it. I think that's the whole function. So now I have to go back to here because I need another, okay, decompressed buffer is, we already have the size of it. It's in compressed file statistics, I believe. Decompressed size is what it is. So that's what we'll pass in here. Large integer, size t. Oh, well, I mean, here's what we'll do. Since I don't really like large integers anyway, I don't like that data structure, how about instead I just make it a unit 64t. How about I do that instead? So copy that. Load aug from memory. Replace that. Okay, and now buffer size no longer has a quad part member because it's simply a uint64, which we are truncating to an int because stb vorbis decode memory takes an int. So we're just letting the compiler know that it's okay to truncate that. I mean, basically the implication here is that this function stb vorbis decode memory can't accept input or any sort of like file that's larger than 4 gigabytes, but that's perfectly fine. We're never going to be dealing with any sort of aug file that is anywhere near 4 gigabytes. So that's fine. Okay, where was I? Is everyone cool here? Load asset from archive. Load wave. Load aug. Okay, that's good. So now I'm going to go back to WinMain. You can see that I've added some more comments in here too. And I'll continue commenting stuff as it continues to, as things get cemented in place more or less, I start commenting them more. But things that I know that I'm still going to be moving around and refactoring and possibly, changing significantly, I tend to leave the comments pretty light on those things until they get sorted out. Anyway, I need to replace this piece. Copy, comment. This is the part where we load aug from file. I'm going to replace that with load aug from memory. No, wait. I did it again. I did this last time too. That's not what I want. I want load asset from archive. Right? Load asset from archive. And it takes in an asset file. The asset file name will just be overworld1.aug because there's no directory structure inside of our thingy. inside of our, archive. What else? We need the resource type aug. And then there's the pointer to the resource. If that does not succeed, then we do load asset failed. What I actually should be doing is I should have an error, a variable to hold the error code so that I can return it, which I will do later because I plan on changing all of these functions. I'm going to put them in their own sort of like asset loading thread, as I talked about at the end of the last episode. But anyway, so I think that does it. Let me go ahead and run this and see what happens. Build started. Excuse me. Come on, come on. There it goes. Alright, and we have music. I think you can hear that. I have the volume turned down really low. But I can hear it. Worked fine. So, awesome. Alright, cool. We might be actually finished all of these. That went by really fast. We might finish all of these today. And then we'll be done with the archive stuff, the mini-Z stuff. Load. Where are you? Load asset from archive. So there was one thing I was thinking about where if you go down these functions right here, load wave from memory, load aug from memory, I was sort of thinking like those functions pretty much only should ever be called from the load asset from archive function. So if you go to each of these functions, is there a way that we could check who called, like who the calling function was, who called us, and say, if the caller of this function was not load asset from archive, then we can, crash, log an error, whatever. And the answer is not really. What we could do is we could actually modify these functions to take in an additional parameter, which would be a pointer to a string, and we could do this, right? And then we could go and do a pound define and have it so that we could basically hide this third parameter here, and I might do that later. I'm just sort of thinking out loud. But that's one way. That was the first thing that comes to mind when you have a function and you want to make sure that that function only gets called from another function, from some other particular function. You could sort of pass in the name of the caller that way. But other than that, I don't think there's any other way to know. There's no way for a called function to know who called him, who called me. I don't think there's any other way to know that. Anyway, on we go. Load tile map from memory. And again, we supply a decompressed buffer. And we probably don't need the size for this one, so I'm just going to do pointer to the buffer. Although we might, I don't really know. Let's go back to main.h. Keyword load tile map from memory in void star buffer in out. What is load tile map from file? It takes a file name and then we have a pointer to a tile map. So we will do that. Okay, main.c, load wave from memory, load og from memory. Alright, I'm going to go find load tile map from file. Copy all this. Which is kind of a lot. Load tile map from memory. There we go. Okay, same as before. We don't have a file, so we don't need file handle. I don't think we need file size. We don't need bytes read. We don't need file buffer. We do need cursor, temp buffer, rows, and columns, though. We're not doing create file anymore, so we can get rid of that. We're not doing get file size ex anymore, so we can get rid of that. Get rid of this log message. Okay, fine. Unit, let's just do unit 32. Okay. Load tile map from memory. Yep, that's fine. Buffer size. Then we need. Well, look at here. I found an error. Because I did file %s. %s is a token specifier. It's supposed to be the name of the file. But look here, I never supplied the name of a file over here, so I actually had a bug that I never knew I had over here. We'll probably have a lot of those. Log create file failed. File name. And what's it called? File name. Yeah, that's right. Okay, let's go back to load og. Make that a 32 instead of 64. I apologize for jumping around, sort of stream of consciousness style. Alright, where am I? Load tile map from memory. Load tile map from memory. There we go. We don't need that semicolon. Do we not have an egg? Do we not? Oh, there we go. Okay, file buffer we no longer need. We no longer need to do a heap alloc there. We don't need this piece. We are no longer reading a file into the file buffer, so that part can go. Now, if cursor is, all right, so this is pretty easy. As you could see, working with a file and working with a memory buffer is pretty much exactly the same. It's all the same. Okay, could not locate the width attribute. Buffer is too small to be a valid tile map. All good there. Okay, found the width attribute. Bytes read equals 0. Oh, we actually did need bytes read, didn't we? What was it, a D word probably? Okay, bytes read, could not locate the opening quotation mark. Making sure this part is all still right. Looks good. Looks good. Looks good. Looks good. Width attribute was 0. Go to exit. Now we're doing the exact same thing, but we're looking for the height attribute. Could not locate the height attribute. Go, go, go. Could not locate the opening quotation mark. All that looks good. All that looks good. Okay. Tile map dimensions. Rows and columns. Okay, now we do need to allocate this memory for these rows, for each row. Let's see, could not find a comma character. We just have to take the file name out because we don't have a file anymore. Okay, row to buffer. I guess that's it. And we don't need to do any of that anymore. File buffer. You know what, actually? So this one is actually different because this one is a little bit different because we remember mini-z as we decompressed the tile map file, which was that TMX file that represents our tile map. Okay, so when we used mini-z to decompress that file from the zip archive, mini-z created a memory allocation to store that decompressed file. But after we actually created a brand new memory allocation in these nested for loops. We created a memory allocation for this two-dimensional array of numbers, basically of tile numbers. We want to keep that, but now that we've done all this, now that we've parsed the file, we don't really need the buffer anymore. We don't need that to stay in memory, the original file. So I guess we could try to free it. I assume that mini-z allocated it from the default process heap. Maybe I should do, I don't know. I guess we'll just run it and see what happens. Run it and see what happens. The reason why I'm thinking about this is because, like, with heap free, you can create as many different heaps as you want. Every process comes with one default heap, which is what you get when you run git process heap. It just returns you the default process heap. But you are more than free to create as many separate heaps as you want. So, with that being said, I really don't know what heap the buffer resides on. I'm just assuming that it resides on on the default process heap, because I didn't allocate it, so I can't say for sure that's where it is. So yeah, just keep in mind that we may have a bug there that I don't understand or know about yet. But let's go finish this. Load asset from archive. Let's make sure this part is right. Yeah, load tile map from memory. Too few arguments in a function call. It needs a buffer size, same as before. Decompressed size. And then a tile map. Now let's go back to WinMain. There's our TMX file where we're loading our TMX file. We no longer need that. Let's instead uncomment. We're going to do load asset from archive. Asset file takes in an asset name, which is this TMX. Resource type will be resource type tile map. And finally, a pointer to the resource. Okay, and if that fails, then we log a message box, go to exit. All right, and now one last thing before we run this. I actually want to go to overworld.c, and I want to uncomment this piece right here, because this is the code that draws the tile map numbers on each tile. I just want to confirm that the tile map is still being loaded correctly. So now I'll start it and we'll see what happens. Okay, we did in fact crash, and I'm pretty sure we crashed because of exactly what I just talked about, where there is buffer. Let's see, copy value, paste it over here, and there it is. This is my XML file. And even though it's not very big, I mean, it's only a few kilobytes, right? This XML document in memory. I don't need it anymore, so I kind of want to free it. But I don't know how. Let's just try MZ free. Okay, let's stop you. Free. It's just a shortcut to free. A pound define. Alright, let me just comment this out for now. I'm not sure what to do with it. Right. Alright, let's run it again and see what happens. Yep, it works perfectly. No, it doesn't. Oh, you know why? I forgot. I never. It does work perfectly. It's just that I never programmed this this code to like pan with the camera, right? So this code that I wrote here, it only works in the very upper left-hand corner of the screen, and that's okay. I mean, that's expected. I wrote that code to draw the ones and zeros and twos on there before I wrote the camera panning code, so we will update that later. Right, so I think our tilemap thing works. Our tilemap loader is working fine. Let's continue on. Load asset from archive. All that's left is BMPX, so error equals load load 32 BPP bitmap from memory. Takes in decompressed buffer. I don't know that we need a size yet, so I'll just leave it at that for now. I'll go add a definition for it over here. Keyword. Load 32 BPP bitmap from memory. In void star buffer, and then in out game bitmap pointer. Game bitmap. Tilemap load. Wave load. Right. Okay. Looks good to me. In void start buffer. In out game persona game bitmap. Okay. All right. Let's go make this thing. Let's go make this thing happen. Find a place to put it. We go find load 32 BPP bitmap from file. We'll copy it. And we paste it right there. Okay, file handle can go. Bitmap header, pixel data offset, number of bytes read equals 2. I forget why I initialized that to 2. I've totally forgotten why I did that. I'm sure there was a good reason for it. We don't need this anymore because we are no longer opening a file. We need to do this. Loading into destination bitmap header. Bitmap header. The source is going to be buffer, and then we're reading, is it 2 bytes? Let me think about this for a second. Yeah, it's just 2 bytes because we're looking for the magic signature of bytes 4D and byte 42 to spell BM for bitmap. So, yeah, I don't think that's necessary anymore, which means we probably don't need that anymore either. We don't need to do this piece. All right, mem copy. Where am I copying? This is pixel data offset. Pixel data offset. The source is going to be buffer plus what? Buffer plus A. Because see, I used this set file pointer to move this far into the file. But obviously that isn't necessary anymore since we're not dealing with a file anymore. We do need to type this because we need to give this a type because it's a void right now. Alright, that can go. Error, file invalid. Error, buffer, or I should say error invalid what? Invalid block, invalid data, sure. Alright, there goes that should be our pixel data offset. Oh, I didn't specify how long it needed to be, so probably size of dword, which is 4 bytes. And I guess if you wanted to be consistent here, you could do size of word. So word is 2 bytes, a dword is 4 bytes, a qword is 8 bytes, etc., etc. Yeah, very well. Don't need that anymore. 0xe. So now what we need to do is we're going to copy into game bitmap, bitmap.info.bmi header. We're going to copy buffer plus 0xe, and then the size is going to be size of bitmap info header. There we go. Now we no longer need this. We don't need to allocate memory for it anymore. So why don't we just do game bitmap memory equals probably buffer plus pixel data offset would be my guess. Alright, let me go ahead and get rid of this because we don't need to allocate memory. The bitmap we need is already in memory. We don't need to set a file pointer. Yeah, this is all it is. So game bitmap memory equals buffer plus pixel data offset. And I guess that's it. We don't need the read file anymore. We don't need to close the file. Loading successful. Yeah, it kind of sucks. I actually don't have the file name anymore. Loading failed. Take the file name away. Alright, I guess that's it. Let's go to WinMain. Copy, comment out, paste, replace load 32 BPP bitmap from file with load asset from archive. We're going to load it from asset file. We're going to load 6x7 font.bmpx. We are going to load resource type bmpx. And the resource, of course, is 6x7 font. And if that fails, then we complain loading failed, go to exit. We'll do the same with this. Load asset from archive, asset file. Name the asset. Asset type, resource type, bmpx. And there's the resource. If that fails, then we complain and we exit. Alright, well, let's run it and see what happens. Everything seems to work perfectly. So since this is a WAV file, let's go ahead and replace this piece. Load asset from archive. Menu navigate. resource type wave. Comment this out. Load asset from archive, asset file, menu choose, resource type wave. Okay, that should be all of our assets except for the hero sprite bitmaps. Oh, build errors. All right, let's see what we got. Okay, conversion from size T to uint 32, which of course is fine. Okay, that's it. All right, so that pretty much concludes all that I really thought I was going to get done today, but it was pretty quick. So I think we have a little bit of time left over to keep going on something new. There's one other thing I wanted to do, and I don't know if you've noticed, but every time we go to load more assets, the game takes a little bit longer and a little bit longer and a little bit longer to start up, and that it's very slight for me. I have a solid state drive and a very fast computer, so you don't really notice that big of a performance impact. But if you're playing this on a much smaller machine with like an old-fashioned spinning platter hard drive, or even worse, like a Raspberry Pi with a SD card as a hard drive or something like this, it would be much slower, and the impact of loading these assets at the beginning of the game would be even more noticeable. So to that effect, I would like to create, I'm still going to load the assets at the beginning of the game, and that's something that we may do later on is, do you want to load all of the assets for the entire game right at the beginning, or do you want to load some of the assets at different points during the game, when you're right before you encounter them? Like, maybe I don't want to load like all of the different tracks of music that I have right up front if you're not going to hear all those different tracks of music, for maybe after a couple hours of gameplay. But at the same time, I think that falls under sort of a performance optimization situation, and I think that, so we don't really have to worry about it right now. I wouldn't worry about performance optimization until we get closer to the end of the game. So I think for now, I'm just going to take the path of least resistance and load everything that I want to load right up front. And what that means is that we need to make a loading screen, basically. Although I don't think I want to create a loading screen per se. I think I want to create sort of like, I want to build the loading screen into the opening splash screen. So you know the opening splash screen, it just like pops up the name of the game studio, it plays this really annoying sound, and then it fades away. Well, what if I load my assets in the background while that's going on, and then I don't allow the game to proceed from the opening splash screen state to the title screen state until after all the assets are loaded? Or maybe I could do where I don't allow a new game to start until all the assets are loaded. I guess in the end it doesn't really matter. But I gotta do something. So here's what I think I'm gonna do. I'm going to create a new global called G asset loading thread. And then somewhere down here in WinMain, okay, right here. So I know that basically I need to load 6x7 font. I need to load that right away because literally the splash screen itself is not possible unless I have 6x7 font loaded. So I think I may actually load 6x7 font on this main thread, because if we don't have 6x7 font loaded, then we can't really do anything else. Like we can't really render any other text at all. We can't even draw the word loading ... to emphasize that we're loading assets. You know what I mean? So I'm going to leave that there because we're going to load that right up front. We're going to load that first. Is there anything else that I need to load? Maybe the splash screen sound. Splash screen.wave. Okay, let me do that. Okay. Load. Oh wait, that is not the right. It's not even the right place. This is the right place. And you know what? Go ahead and get rid of that. Okay. Load 6x7 font and splash screen.wave before proceeding. Then we can load all of the other assets on a separate asset loading thread. And then we can display a loading message until that thread is finished loading assets. Does that sort of get my message across? But we couldn't even draw the text to say loading without having 6x7 font already loaded, so make sure that it's loaded first. Alright, so hopefully that gets my message across. So we're going to load those two in serial, and after that we are going to create a new thread. So creating new threads in Windows is actually very easy. We're just going to do g asset loading thread equals create thread, and we need we don't need to supply anything for thread attributes. We don't need to supply anything for stack size. If I remember correctly, every thread that you create gets a default user mode stack size of 1 megabyte. That is configurable. In the compiler, you can go in here and tell Visual Studio, hey, I want 10 megabyte stacks for all my threads. But by default, if you don't ask for anything in specific, Windows will give you a 1 megabyte stack by default for each thread. In contrast, in kernel mode, since historically the memory has been much tighter in kernel mode, much more restricted in kernel mode, and this was back when we used x86 or 32-bit Windows. We used to not have very much kernel mode memory to play with at all. Now that we have x64, 64-bit Windows, it really alleviates all of that, memory sort of memory pressure. But the point I'm trying to get at is that in Windows, your default kernel mode stack size is only something like, I think it's something like 12 kilobytes, which is really small. But of course, we're creating a user mode thread here, so this is we get a 1 megabyte thread stack by default. Okay, so we need a thread start routine, which I haven't created a thread start routine yet, so I'm just going to call it something like asset loading thread. No, thread proc, thread procedure, asset loading thread proc. That sounds good to me. And then we're not passing any parameters. Creation flags is probably nothing. We're not specifying anything special there. And then thread ID. I guess you could specify your own thread ID, which is weird. I don't know what that. You know what? Instead of just guessing, why don't I go look up the documentation? Win32 create thread. Yeah, see, you can actually create the thread in a suspended state. Okay, a pointer to a... Oh, okay. No, you can't request a specific thread ID. That would be silly. This is a pointer to a variable that receives the thread identifier that Windows gives you. So that can be useful if you want to try to identify threads by their ID later on. Like if thread ID is important to you for some reason, then you might want to capture the thread ID that Windows gives you when you create a new thread. There's something that I was thinking of. As of Windows 10 1607, that's Redstone 1, came out in 2016. They created a new thread description, so you can actually add descriptions to your threads. Two things though, I see that they have not modified the create thread API to include, they don't let you specify a thread description here. And I think the main reason why they will never do that is because create thread is an ancient API, and you can't just go change. You can't just go and change the create thread API, because there are thousands and thousands of programs out there that have relied on it for decades, and it basically can't change at this point. It's calcified, and if you tried to change it, it would break backwards compatibility. And say what you will about Microsoft Windows, but they are very, very, very good about backwards compatibility. So anyway, do I care about thread descriptions? What would you use thread descriptions for? The answer is debugging mostly. It's purely a debugging feature, is what thread descriptions are for. I think there's probably another API called, it's probably like set thread description or something like this. Thing is I don't really care. I'm not going to use it, and I'll tell you why in a second. Win32 set thread description. Yep, yeah, set thread description. You give it a thread, you tell you what you want its description to be. And of course, in my case, the description of this thread that I'm creating would be something like asset loading thread. And that would help me in debugging, because later on, if I'm debugging a memory dump of this program or whatever, I might be like, hey, I wonder what this thread does. Well, now the thread can have a nice human-friendly description. Friendly, human-readable. But here's why I'm not going to use it, is because it is new to Windows 10 1607, and I don't want to necessarily do anything that would shut out people who are still using Windows 7 and Windows 8, God forbid, from running this game, especially just for something stupid like thread descriptions. If you're doing something like, if you're doing like some awesome graphics that require DirectX 12, in that case, then you'd be like, yeah, you need Windows 10 to run this. But for something like thread descriptions that don't really offer much value, that's not a good enough reason for me to like shut out old versions of Windows. So I'm not going to do it. Anyway, thread ID, don't care. Okay, so two things I'm going to do if that equals null. If the result of this equals null, that means that create thread failed, and that I also failed to get the required number of parentheses in here. Okay. Okay, that failed, and if it failed, then we need to just complain and exit the game. Create thread, failed. Create thread failed, error. It's fine. Okay, now the second thing I need to do is I need to go and create asset loading thread proc. And I named it asset loading thread proc. It's going to be a function. Proc is short for procedure, but I don't want to get it confused with this global variable g asset loading thread. G asset loading thread handle. I don't want to get too verbose with the variable names, but I also don't want to get them confused with one another. So, I don't know. Anyway, better go define this thing. So I'll make it right here. Keyword asset loading thread proc. And it's going to take in it's just going to take in a LP param, a pointer. Okay, and then I need to make a definition for it in main.c. dword error equals error success. Exit, same as I always do, return error. Okay, so now this will be launched on a separate thread, which means, if I go back up here to WinMain, this means that when I go and create this thread right here, when I create this thread, this will not block, okay? I mean, as soon as this thread is created, asset loading thread proc will begin running on a separate thread. Meanwhile, I'm going to keep going. I'm going to keep executing. I'm going to keep doing whatever it is that comes next on this thread. Meanwhile, the asset loading thread is going to keep running in parallel. Now, if you have one processor, then the Windows thread scheduler will sort of like, balance the time needed on, by all the threads on the machine on that one CPU. But if you have multiple cores, which most people do these days, I mean, even cell phones have multiple cores these days, you're really going to be doing things in parallel. I mean, there's going to be multiple operations going on different cores of the processor, of the CPU. So what does all this mean? Basically, what I mean is I want to delete this, and I want to start loading everything on a separate thread. Like that. We're over time too, which kind of stinks. Overworld TMX, that's fine. Load that. What else? The OGG file. Splash screen, menu navigate. Menu nav, menu choose. Overworld1.og, all these things. Okay, perfect. Grab these three assets and put them in loading in asset loading thread proc. Okay, so here's the thing. We need some way to synchronize these two threads. I need some way of signaling this thread right here, this asset loading thread proc. It needs some way to like set a flag so that my other thread, my main thread, knows that the asset loading thread is finished. Like, hey, I'm done with my work. And the answer is going to be something like set event something or other. So in the Windows API, you can create an event, and if you call set event from another thread and then check that event from another thread, then you can synchronize all your threads that way. So let me see if I can go ahead and, you know what, on second thought, I don't need to do that. I don't need to do set event. In Windows programming, and this is actually really, I hope that some of you stayed to the very end of this video, because this is actually a really important lesson when it comes to programming Windows and writing Windows applications. So when you write Windows applications, most applications these days, other than just like trivial Hello World style programs, have multiple threads in them. And you need ways, there are multiple ways to synchronize threads, there are multiple ways to synchronize access to data. So, for example, when you have multiple threads that are working on the same piece of data, you need a way to serialize their access to that data. You can't have two threads reading or writing, especially not writing, to the same data at the same time. Or else you're going to end up with undefined, unpredictable, undesirable behavior. So Windows has a major concept called wait for single object and wait for multiple objects. So anytime you have a thread and you want your thread to wait on something, you call wait for single object. I'll look it up right here. Wait for single object. You call wait for single object, and you tell Windows what you want to wait on, and you tell it how long you want it to wait before giving up. Now, you can wait for a single object, or you can also wait for multiple objects. You can wait for a collection of objects. So say, for example, you could have 12 threads. You can have a whole pool of worker threads, and you have one main thread that says, I don't want to proceed until all of these threads are finished. So you call wait for multiple objects, and you specify all those thread handles and say, just wake me up when all those threads are finished, when they've all exited, I guess. So, but the thing is, with wait for single object and wait for multiple object, you can wait on lots of different types of objects. That's why it's called wait for single object, because there are lots of different kinds of things that you can wait on. So a thread, you can actually wait on a thread handle. And here is the list right here. The wait for single object function can wait on the following objects: change notification, console input, event, memory resource notification, mutex, process, semaphore, thread, waitable timer. So I don't have to worry about setting an event. I mean, I could probably do something with setting an event, but I don't have to do that. I can wait. Thread A can call wait for single object and simply wait on thread B. And here's the other important thing, is that it doesn't necessarily have to be a blocking wait. I can sit in a loop and do it. I can call wait for single object in a loop, and if that object that I'm waiting on is not done yet, or it's not signaled yet, then I can just proceed with whatever else I want to do. And that's how we achieve all of these beautiful things that we have here, like with Windows, where you can wait on things, but the GUI is still responsive. You have multiple threads in the background that are all doing things. They're all synchronized in very elegant, very complex ways. It basically all boils down to the magic of this wait for single object or wait for multiple objects API. It's one of the most powerful and most fundamental functions in the Windows API. So yeah, I think that's about all I have to say about that. So here's what I'm going to do. Is I don't have time to do it today because we are well out of time. We're at like an hour and 15 minutes. So next time what I'm going to do is I'm going to, over here in, like, let's say, I don't know, let's pick something like opening splash screen. Okay, now we have a draw where we don't want to, we want to keep drawing the splash screen until the assets are finished loading. We can't stop doing this. Like we can't suspend this thread. We can't block this thread while we're waiting for the assets to finish loading, because if we did that, the text wouldn't display, the sound wouldn't play, there would be no animation, no fading, nothing could happen, because this thread would be blocked on wait for single object and it couldn't proceed. So the way to do it is that you call wait for single object and with with no timeout at all, and it will basically just tell you whether the thing that you're waiting on is signaled or not. And if it's not, then you can go on your merry way. So basically what I'm going to do here is somewhere in draw opening splash screen, I'm going to do something like this. Okay. Now, remember, the logic we have here is that if the local frame counter is greater than or equal to 240 frames, then at that point we're automatically going to proceed to the title screen. But we're going to change that now to where now if we're at 240, we're going to proceed to the title screen, but only if the asset loading thread has completed. So what I'm going to do is if wait for single object, and then the handle is that global handle which is in the main.c file, which I need to change. Forget all about that set event thing, don't need it. But this needs to be, there we go. Take that out of there, put it in main.h so that I can share it among multiple source code files. Where are you? Where are you? Where are you? Here we go. Right there. There we go. There. Wait for single object, wait on that thread handle, and then wait for 0 milliseconds. That means don't block at all. Don't suspend this thread while you're waiting. Just tell me what the current state of this thing is. And there's I don't know why it's called wait object 0. We can go look it up, but basically it means if this thing is not done, then let's see, wait for single object if it is not equal. Let's go look it up. The state of the specified object is signaled. So that means it's done. Like if this thread has run its course and has exited, then it will be signaled. So if it has been signaled, then at that point we're going to change to a we're going to change to the title screen game state. I think, and then like if the thread is not done, then we are probably going to draw loading text. And I'll probably put it down in the corner or something like this to let you know that assets are still loading, and I can add animation to it and all this kind of stuff. Because cool thing is like this, like I said, this doesn't block. So it's simply checking if that thread is done yet or not. And the effects, let's go ahead and run it and see what happens. This is another pretty exciting moment, I think, because this is like the first time we've ever used multithreading. And of course, all of the assets were already done loading, so you didn't really notice that much of a difference. But everything still works fine. So even though we had a separate thread. Okay, so I can think of one other thing that will really emphasize the point that I'm making here. So if I go back to main.c I go back to asset loading thread, go all the way down to the bottom, so it's done all this work, and then I do a sleep for 10 seconds. I want you to observe how this changes the behavior. So what I predict will happen is, since that event that we're waiting for on our main thread, which is the termination of this thread, since that event won't happen until after the sleep is done, there should be a 10-second delay. We should be stuck staring at the splash screen for an additional 10 seconds. So let's pretend like this right here, this 10-second sleep, let's pretend like that represents us loading a whole bunch of extra assets, a whole bunch of new music and bitmaps and stuff like this. So let's just run it and see what happens. Alright, so splash screen faded out, and we're still here. We're still here. We're stuck here. We're stuck here. And finally the title screen comes up. So there you have it. Okay, so we're way over time. This is really cool. We're going to continue to enhance this next time. And what else? Okay, so I'm going to call it for today. As always, thank you very much for watching. If you enjoyed the video, please like and subscribe and leave your comments below. If you have any comments on any of the material, it could be about any episode, please don't hesitate to leave a comment. I will address any interesting comments and or questions in an upcoming episode. Also, don't forget that we have a companion GitHub repository to go along with this, so it's all open source. You can go and download it. You can go and clone the GitHub repository so that you can follow along at home. So with that, I thank you again for watching, and I will see you in a few days. All right, bye.